Was Japan's semiconductor industry really destroyed by the United States? It's true that the island nation's semiconductor industry has lost its former global standing. In 2021, none of the top 10 semiconductor companies by revenue were from Japan, while 6 were from the US. According to data from Japan's Ministry of Economy, Trade and Industry, in 2019, Japan held a 10% share of the global semiconductor market. This isn't low, but over 30 years ago, in 1988, this figure was an astounding 50.3%. The market share plummeted from 50% to today's 10%. A popular narrative is that US trade sanctions crippled Japan's semiconductor industry. But is this influential industrial shift really just a cliche story of a big country bullying a small country? Hi, my name is Yi, and today we are going to discuss the rise and fall of Japan's semiconductor industry, the little-known love-hate relationship, and the complex emotions between Japan and the United States. Semiconductor chips, found at the core of electronic devices like smartphones and computers, can be traced back to their origin at Bell Labs in the United States. In December 1947, 3 engineers at Bell Labs assembled the first-ever prototype transistor using semiconductor materials. Though initially bulky, it would eventually replace bulky and inefficient vacuum tubes, leading to the miniaturization of computing devices and the rise of essential smart devices in our daily lives. The first transistors weren't as small as they are today and used germanium, which had lower thermal stability and higher cost compared to silicon. It was difficult to mass produce, and thus had limited commercial potential. At the time, Bell Labs' parent company AT&T was under antitrust investigation, making it hard to monopolize that technology. So, in late 1951, transistor patents were made available for a licensing fee of $25,000, granting access to technical information and production rights. In April 1952, AT&T held a technology sharing event for buyers who had paid the licensing fee, inviting them to the US to learn the technology and visit factories. Among the 40 companies that attended was a small Japanese company from Tokyo called Tokyo Tsushin Kogyo, or TDK for short. In English, the name means Tokyo Communication and Industry Company. Despite its grand-sounding name, this company was quite small. So small, in fact, that it didn't initially qualify to attend the seminar. As a defeated World War II nation with a severely damaged economy, Japan had strict controls on foreign exchange. To spend $25,000 on a license, companies needed approval from Japan's Ministry of International Trade and Industry, or MITI for short. When compared to larger enterprises like Toshiba, Hitachi, and Mitsubishi Electric, TDK's application was rejected due to their perceived lack of capability. Undeterred, TDK went ahead and signed a temporary contract with Western Electric, a subsidiary of AT&T, without MITI's approval. This act of defiance displeased MITI officials, who refused to approve the contract, leaving TDK's semiconductor production in limbo. However, their luck came when the leadership of MITI's electronics division was replaced at the end of 1953, providing an opportunity for their license to be reconsidered. TDK later successfully produced the compact TR-55 radio using semiconductor transistors. Before the TR-55, most radios were large appliances that sat on tables. The TR-55, on the other hand, was small enough to fit in one hand. Although it was released after the Texas Instruments Regency TR-1, the TR-55 was more affordable. While the TR-1 was more of a showcase for Texas Instruments to promote transistors, the TR-55 was positioned by TDK as a mass consumer product, successfully opening the portable radio market. Following their initial success, TDK launched a series of smaller and better quality transistor radios that achieved massive commercial success worldwide. In 1957, they released the TR-610, which sold over 500,000 units globally by 1960. Subsequently, established Japanese companies like Toshiba and Hitachi also entered the consumer electronics market pioneered by TDK. By 1962, Japanese companies had sold over 10.5 million transistor radios to the United States. The $12,000 transistor patent license AT&T sold to Japan just a decade earlier allowed Japanese factories like the TDK to earn $77.5 million in 1 year, and that was just from radios. This brief origin story serves as a perfect microcosm of the broader history of the Japanese and American semiconductor industries that we are discussing today. The lucky guy, TDK, later decided to make their name easier for overseas consumers to remember and understand, and they changed their name to the one we all know very well today, Sony. Akio Morita, one of Sony's co-founders who decided to invest in transistor technology, explained why they chose this direction. In the early days, producing semiconductor transistors was challenging, with a mere 5% yield rate even in the United States, where the technology originated. This made production costs extremely high, so transistors were primarily used in cost-insensitive sectors like military defense. Morita believed that this was precisely where Sony's opportunity lay because Japanese companies excelled at optimizing production lines, streamlining processes, improving yield rates, and reducing manufacturing costs. As it turned out, Morita's assessment of domestic companies was accurate, and for a long time, this statement encapsulated the relationship between the Japanese and American semiconductor industries. The US tackled technology, while Japan handled production. American laboratories would innovatively develop technological breakthroughs, allowing them to leisurely enjoy the fruits of intellectual property through patent licensing and consulting services. Because of their technological lead, American companies could thrive in high-cost but high-profit niche markets. Meanwhile, Japan, following in the US's technological footsteps, could only make money from labor-intensive manufacturing, catering to the more limited-profit mass consumer market. However, due to large volumes, optimized production lines, and low costs, Japan's total earnings turned out to be much higher. However, Japan's days of supporting the US didn't last long, and it wasn't due to any scheming, but rather the objective progression of technology. Beginning in the 1960s, the United States entered a phase of explosive growth in semiconductor technology. Japan, always trailing behind and lacking the foundational research strengths of the US, struggled to keep up. In 1958, Jack Kilby of Texas Instruments invented the integrated circuit. As mentioned earlier, the significance of the semiconductor transistor was to reduce the size of electronic devices. Integrated circuits took this a step further by etching the circuitry, originally made of metal wires, directly onto a semiconductor board, reducing the size of the circuits by an order of magnitude. Just a year later, Robert Noyce from Fairchild Semiconductor invented the monolithic integrated circuits, allowing components like transistors to be directly built into the board. With boards pre-designed, complete electronic chips could be mass-produced like photocopying documents. In just 1 year, 1960, Noyce successfully implemented his design on the more stable silicon material. In 1961, Fairchild Semiconductor used their 1959 invention, the planar process, to mass-produce silicon chips for the first time. They introduced the MUL 914, the first commercially available and mass-produced integrated circuit chip, albeit with a simple structure. These breakthroughs happened within years, even months of each other. That was really a technology explosion. In just a few years, the US's semiconductor technology had surpassed Japan by several generations. With the higher stability of silicon materials and the rapid mass production of integrated circuits, Japan's efforts to optimize transistor production efficiency fell short compared to the industrial capabilities and product quality of their US counterparts. In the face of absolute technological disparity, organizational structures and production line optimization became meaningless, much like how nomadic cavalry stood no chance against a torrent of steel from a tank regiment. Japan's transistor-based radios couldn't compete with the US integrated circuit technology used in missiles and spacecraft. In a 1964 analysis article written by Robert Noyce, he estimated that 95% of chips that year would be used in military and aerospace applications. The most famous example was the Apollo moon landing project, where each spacecraft's navigation computer required 5,000 integrated chips. This cutting-edge project further refined chip production technology, and by the time the computers for the lunar landers were in production, the price of integrated chips had dropped from $1,000 per piece to $20 to $30, making them increasingly accessible for consumer markets. Logically, the next part of the story should have been Japan's electronic factories being crushed by the integrated circuit technology. However, in a surprising plot twist, those Japanese transistor experts, who should have been defeated by integrated circuits, managed to gain ground in the global semiconductor market. This was due to the common advantages of Asian countries, large markets, and lower labor costs. These factors allowed Japan to maintain and even increase its influence in the face of technological disparity. For example, in 1962, Robert Noyce, previously mentioned, represented Fairchild Semiconductor in negotiations with Japan's Ministry of International Trade and Industry. He practically begged Japanese companies to buy their integrated circuit patents so they could set up factories in Japan. In the 1963 agreement, Fairchild Semiconductor's Japanese factory had to form a joint venture with Nippon Electric Company, and the Japanese company could hold all rights to integrated circuit patents within Japan, including licensing fees. But that wasn't all. Contrary to the image of Japan always being pressured by US trade policies, in April 1966, Japan actually introduced a semiconductor ban. This ban prohibited integrated circuit chips with more than 34 components from entering the Japanese market. Using Japan's consumer and production power as leverage, a series of patent licensing and protection policies allowed Japan's semiconductor industry to continue growing. After dominating the transistor radio and television markets, Japanese companies found another large consumer market for integrated circuits, electronic calculators. By the early 1970s, Japanese Casio calculators had an impressive 80% market share in the US. Meanwhile, US exports of electronic products to Japan, excluding core technology components, plummeted, and the trade deficit grew. In 1972, the US finally recognized the problem and launched a calculator dumping investigation against Japan, refusing to continue supplying integrated circuit chips. The US's domineering style in international trade was also evident. Japan had to exchange labor for chip patents and protect its domestic market through product bans. Japanese companies had to find ways to succeed in overseas competition, which was standard business practice. The US's approach was different. In addition to trade policies like chip export bans, the US used the return of Okinawa as a condition to demand Japan open its domestic electronic market, directly exchanging military power for market share. Japan reluctantly agreed to this unequal treaty, which was sensitive for domestic media, who compared it to the Black Ships incident that forced Japan to open its borders in the past. Japanese companies felt humiliated, and Japanese scholar Makoto Kikuchi recalled, the more Japan produced, the more patent fees it paid to the US. As long as they had massive funds, the US would continue to lead the era and introduce new technologies and equipment. The real problem was that without advanced semiconductor chips, Japanese companies could only produce low-end products, resulting in a significant decrease in export volumes. Within just 2 years, their market share in the US calculator market plummeted to a mere 27%, and being phased out was just a matter of time. In the era of free markets, the Japanese semiconductor industry didn't perish due to technological lag, but when US political power intervened, Japanese electronic factories were hanging by a thread. However, desperate times often lead to miraculous results. Under the guidance of the Japanese government, the Very Large-Scale Integration Project, or VLSI for short, was launched. The Ministry of International Trade and Industry brought together Hitachi, NEC, Mitsubishi, Fujitsu, and Toshiba to consolidate Japan's official industrial and academic semiconductor resources. The companies abandoned their barriers and collaborated on semiconductor research and development. Starting in 1976, the project received an investment of 73.7 billion yen, with 29.1 billion yen coming from government subsidies. Semiconductor chip manufacturing plants sprouted up on Kyushu Island, boasting remarkably high efficiency from research to production. The project focused on two goals: developing VLSI production equipment and finding high-quality semiconductor materials. Participating companies worked in harmony, sharing resources and showcasing their strengths. The internal production lines operated in a competitive horse racing mode. Within just 4 years, the project generated thousands of patents, ultimately bearing fruit in DRAM memory chips. In Japan at that time, a single company could simultaneously run 16K, 64K, and 256K memory chip production lines. By 1980, Japan's chip exports surpassed the US, making them the world leader. By the mid-80s, the Japanese semiconductor industry not only achieved the self-sufficiency goals set by the VLSI project, but also reached the global pinnacle, with NEC, Toshiba, and Hitachi occupying the top 3 spots. In March 1980, at a semiconductor conference in Washington, a Hewlett-Packard executive revealed a shocking fact. Although memory chips were invented in the US, 16K memory chips produced in Japan were of higher quality and more durable, meeting Hewlett-Packard's requirements and at no additional cost. Consequently, Hewlett-Packard heavily relied on Japanese memory chips. From 1978 to 1986, the US's global market share in DRAM memory chips plunged from 70% to 20%, while Japanese companies' share skyrocketed from under 30% to nearly 80%. In fact, it wasn't just memory chips. The high quality and low price of Japanese chips put pressure on the entire US semiconductor industry. In a 1981 report by the New York Times, investment banks predicted that the average profit decline for leading semiconductor companies like AMD, Intel, Motorola, National Semiconductor, and Texas Instruments would exceed 67% that year. Intel's annual report for 1981 showed a 7.7% decrease in total revenue. It might not seem that bad, but the net profit after deducing costs dropped by over 70%. By 1985, the situation hadn't improved. For Intel, the year marked the birth of the 32-bit 386 microprocessor, which led the PC era. If not for this event, Intel might have wished to erase 1985 from history altogether. The company laid off 900 employees, closed 2 factories, and exited the DRAM memory chip market, a series of bad news. What shocked the US semiconductor industry even more was the 1986 announcement that Japan's Fujitsu would acquire 80% of Fairchild Semiconductor's shares. As we mentioned earlier, Fairchild Semiconductor was one of the birthplaces of integrated circuit chips. Most of the top executives in the US semiconductor industry had worked at Fairchild, which earned it the nickname Cradle of Silicon Valley. From the early 1960s, when chip technology took off, American and Japanese semiconductor companies had a vague relationship for over 2 decades, but now the US was on the verge of losing control. To be precise, Fairchild had been sold to French oil company Schlumberg in 1979. The French weren't heavily involved in semiconductors, but Japanese companies were direct competitors in the chip sector. So the French were acceptable, but the Japanese were not. Even though the acquisition's damage was limited due to expiring patents, the symbolic insult was unbearable. Japan's lead in the semiconductor field did pose a real threat to the US. The famous book Japan Can Say No stated, "Only Japanese companies have the capability to mass-produce high-quality gigabit semiconductors. Without using Japan's next-generation semiconductor chips, US nuclear weapons cannot be precisely targeted." If Japanese computer chips were sold to the Soviet Union instead of the US, the global balance of military power would be rewritten. Although exaggerated, the statement had some truth to it. While the US wouldn't necessarily struggle to make missiles without Japan's companies, the massive electronics industry would have a hard time recovering quickly. It was challenging to find domestic factories with similar production capabilities. Feeling threatened, the US turned to trade policies once again. In June 1985, American semiconductor manufacturer Micron filed an anti-dumping lawsuit against Japanese 64K DRAM memory chips. By September, Intel, AMD, and National Semiconductor followed suit with similar cases. In December, the US Department of Commerce took the rare step of initiating its own anti-dumping litigation against 256K and future generations of DRAM memory chips. In 1986, the US-Japan Semiconductor Agreement was signed, requiring Japanese companies to accept US export price monitoring and anti-dumping supervision. However, the policy's effectiveness was limited, and export restrictions even led to higher profits for Japanese companies. With limited success, the US resorted to strong-arm tactics. In 1987, they imposed sanctions on Japan based on the Semiconductor Agreement, claiming that Japanese dumping in other countries and regions affected the US market. Although Japan insisted they did not breach the agreement and provided data to show their market share was declining in other countries, the US ignored this and announced 100% punitive tariffs on $300 million worth of Japanese semiconductor imports in April. This move affected the entire Japanese semiconductor industry, from small items like discs and digital watches to large ones like commercial satellites. Just before this, in September 1985, Japan has signed the well-known Plaza Accord with the US, promising to intervene in currency markets to devalue the dollar against the yen to promote US exports. This led to an uncontrolled appreciation of the yen and the eventual collapse of Japan's economic bubble as the real estate market crumbled. Under these circumstances, the Japanese semiconductor industry suffered significant damage and spent a long time recovering, unable to keep up with rapid technological advancements. Meanwhile, the global electronics market welcomed a new technological revolution, transitioning to the era of high-performance central processing units and the booming personal computer market. Chip design outsourcing became the new production model. Japan, lagging behind at this crucial point, maintained advantages in storage, semiconductor manufacturing, and materials, but could never regain its former market position. Looking back at this history, the bottom line is that science and technology are the primary productive forces, but there are different levels of importance within technology. While production line optimization and personnel management are crucial, the real value creators and those least affected by external factors are fundamental research. No matter how extensive the US sanctions, they couldn't shake Japan's position in storage and semiconductor production equipment. Fundamental research is the primary force within the primary productive forces. That's it for today's video. If you liked it, please hit the like and subscribe button, and leave your thoughts in the comment section. This is E from Unitech, and I'll see you in the next one.